So this is CBE 2, starting with question 8. And we have the equation 4 cosine of x minus 3 is equal to 0. We want to know what are the solutions to the equation in the interval 0 to 2 pi. So if we have 4 cosine of x minus 3 equals 0, then we can add 3 and divide by 4. So the cosine of x equals 3/4. Okay, and it wants our answers in radians. How do I know that? Because it gave us an interval in radians. So the cosine of x is adjacent over hypotenuse. So where will the adjacent over hypotenuse be equal to 3/4? Well, that has to occur in quadrant 1 or in quadrant 4. Oh, that's not H. Sorry, H goes here. Okay, so what angle here will give me a 3 and a 4? So let's just do the cosine inverse of 3/4, and that will tell me my angle. Maybe I should call this theta. Okay, so in our calculator, we're going to do, well, first we got to make sure we're in radians. And cosine inverse of 3/4, and I get 0.722. So this angle right here is 0.722 radians. So how do I figure out what this angle is? Well, that is a full circle minus 0.722. So a full circle is 2 pi minus 0.722, and I get 5.56. Okay, let's do another one. What if I had -3 sine of x is equal, no, plus 5 equals 0? Oh, nope, let's say -5. Nope, +5. I like that better. So the sine of x is equal to 5/3. So in quadrant 1, that would be a 3 here and a 5 here, and I want this angle. So the sine inverse of 5/3 will tell me angle theta. So the sine inverse of 5/3, or no, sorry, 3/5. I did that backwards. And I get 0.64644. So this should be 3/5. So theta is 0.644 radians. Well, in what other quadrant will the sine equal 3/5? Well, let's check quadrant 4. That won't work. So yeah, it can't be 4, it can't be 3, it's got to be 2. So 3 and 5, and I know that this angle is 0.644. So what is that angle? Well, that is pi, which is half of the circle, minus 0.644. And that will tell you both angles that have a sine value of 3/5. Does that make sense? Okay, that one should be really easy. I don't think I messed up a single time. All right. All right, there are probably a lot of ways to solve this. And we're looking for every answer that occurs in 2 full rotations. So we need to simplify this down into something that is just sine or cosine or tangent or I guess we could do cosecant or cosecant, or secant and cotangent. So whenever you're simplifying, it's usually a good idea to turn all tangents and cotangents into sines and cosines. So let's try that. So the cosine, and all of these angles are the same. They're all x's, so I'm not going to bother writing them. If it was x's and 2x's, then I would need to write them, but in this case I'm not going to. So cosine times cosine over sine plus sine is equal to 2. Okay? And that gives me cosine squared over sine plus sine is equal to 2. Let's get a common denominator. So I'll times this by sine over sine. And that gives me cosine squared plus sine squared over sine is equal to 2. Any of those look familiar? Yeah, if we look at our Pythagorean identities right here, sine squared plus cosine squared is 1. So this is just a 1. And I get 1 over sine is equal to 2. So we could say the cosecant is equal to 2. Or I like sines and cosines better. So cross multiply 2 sine is equal to 1. So the sine is equal to 1/2. And that's nice because these numbers are in the unit circle. So we go to our unit circle. Where is the sine equal to 1/2? So that would be a y value equal to 1/2. So pi over 6 and 5 pi over 6. So pi over 6 and 5 pi over 6. Is that all of them? No, because I have to go all the way around. This is from 0 to 4 pi. So we did this and we did this, but we got to go all the way around to there. What would that be? That would be pi over 6 plus 2 pi. Well, another way to write 2 pi is just 12 pi over 6. So we add those together and we get 13 pi over 6. If I kept going to here, that is essentially 2 pi plus 5 pi over 6. And 2 pi is also known as 12 over 6. So 17 pi over 6. Let's see how I did. So pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. All right, let's find another example. Oh, right there. All right. So I'm going to start by turning the tangent into a sine over cosine. So root 2 cosine plus root 2 sine times sine over cosine plus 2 equals 0. Okay. Well, let's move this to the other side. So we have a 2. So now, well, that's gone. Okay. And then both of these have a root 2. So I'm going to divide by root 2. All right. Now on the left side, we have cosine plus sine squared over cosine. Let's have a common denominator, cosine over cosine. So the top becomes cosine squared plus sine squared over cosine is equal to 2 over root 2. And once again, this is just 1. So I get 1 over cosine equals 2 over root 2. And then I could cross multiply and do a lot of fancy stuff, but I'm just going to flip everything upside down. And I get the cosine equals, oh, it's negative, right? That was negative. So the cosine is negative root 2 over 2. Okay, now we pull up our unit circle. And we're looking, give the exact values of the solution. Oh, I can't see it. From 0 to 4 pi again. So unit circle. I want to know where is the x coordinate equal to negative root 2 over 2. So that would be in quadrant 2 and in quadrant 3. So the answer is 3 pi over 4. That's the one that's in quadrant 2. And then 5 pi over 4. That's the one in quadrant 2 or 3. But now I need to go around to there, which is essentially this one plus 2. And 2 is also known as 8 pi over 4. So we have 11 pi over 4. And then we're going to add 2 to this one, which is adding 8 pi over 4. And we get 13 pi over 4. So those aren't too bad. All right, last one. Okay. So here we have a trig function. Notice we have a double angle on the inside. So that's probably going to tell us we want to use the double angle formula. And again, there are going to be a ton of different ways to do this. So 6 cosine of x equals 4 times the sine of 2x sine of x. Oh, this is going to be tricky. All right. So I'm going to use this double angle formula. So I will replace the sine of 2x with that. So 6 cosine of x equals 4 times 2 sine of x cosine of x times the sine of x, which simplifies down to 6 cosine of x equals 8 sine squared. And they're all x's now, so I'm going to stop writing them. Sine squared cosine. All right, let's look at this for a second. What would be the easiest solution to this? Just looking at it. Well, I want to divide by the cosine, right? I want to turn this into, if I divide everything by cosine, then I get 6 equals 8 sine squared. Is that allowed? Yes, as long as the cosine is not equal to 0. That would make it undefined, right? But what if the cosine is 0? So if the cosine of x is 0, then this becomes 0, and this becomes 0, and the equation works, right? So where is the cosine equal to 0? So cosine is the x value. That would be 90 degrees and 270, right? So the most simple answers to this would be pi over 2 and 3 pi over 2. And we don't care what the y value is of those, because the cosine value is going to be 0, and it's going to break the whole, not break the equation, it's going to satisfy the equation. Okay, so if the cosine equals 0, then this equation is satisfied. So what if the cosine is not equal to 0? Well, if it's not equal to 0, then I'm allowed to divide, and I get this. Divide by 8, I get 3 over 4 equals the sine squared. And remember, the sine squared is really this, the sine of x squared, right? So now we square root everything, and I get plus or minus the square root of 3 over 2 equals the sine. Looking at the unit circle, where is the sine equal to the square root of 3 over 2? And it's actually plus or minus the square root of 3 over 2. So this angle works. This angle works. But so does this angle, because I have negative root 3 over 2. And so does this angle, because I have negative root 3 over 2. So the answers are pi over 3 in quadrant 1, 2 pi over 3 in quadrant 2, and then 4 pi over 3, which is in quadrant 4, or 3, and then 5 pi over 3, which is in quadrant 4. So that's kind of tricky. So are you allowed to divide by the cosine? Yes, as long as the cosine is not 0. And if the cosine is not 0, then this represents all your triangles. But if the cosine is 0, then the equation satisfies itself. And so we have to throw those in as answers. All right, let's do another one. All right. So, according to my reference sheet, the sine of 2x is equal to 2 sine of x cosine of x. So I'm going to stick this stuff in here. And then I'm going to quit writing the x's. So the cosine of x equals 2 sine of x cosine. Oh, I said I was going to stop writing the x's, but I didn't. Okay. So that becomes the cosine equals 2 sine squared cosine. Well, I want to divide by cosine to get rid of those. Okay. So if cosine is not 0, then it simplifies down to 1 equals 2 sine squared. So we divide by 2. So 1/2 equals the sine of x squared. So I take the square root, and I get plus or minus 1 over root 2. And then we have to rationalize the denominator. So that's plus or minus root 2 over 2 equals the sine. So where is the sine equal to plus or minus root 2 over 2? That would be the 45-degree angle in any quadrant. So in quadrant 1, it's pi over 4. In quadrant 2, it's 3 pi over 4. In quadrant 3, it's 5 pi over 4. And in quadrant 4, it's 7 pi over 4. Now, all of those answers are true as long as the cosine is not 0. But what if the cosine is 0? So let's go back here. If the cosine is 0, I get a 0 here and a 0 here, which wipes everything out, and we get an equality. So if the cosine is 0, this equation is also true. Where is the cosine 0? At pi over 2 and 3 pi over 2. So those are my 6 answers. All right, now you can do it.